Alright everybody, here we are in section 3. We've just talked about scalar multiplication, and that's a pretty basic multiplier, just on the edge of the matrix. But today, on this video, you're going to kind of venture into the idea of multiplying two matrices altogether. It's a lot harder, but there is a pattern to it, and sometimes it won't work, and you'll be able to recognize that pretty easily. So 4.3 multiplying matrices. So I want you to make sure that you always look carefully at the dimensions. The dimensions are going to tell you whether or not you can multiply matrices or not. And they also tell you what your result is going to look like. So when you multiply, say, a matrix A and B, if they have dimensions, we'll say 3 by 2 in this case, so 3 rows and 2 columns. And this one has 2 rows and 5 columns. In red, you notice I put a little note here that they match. So the columns of A and the rows of B, if they match these two inside numbers, then you are allowed to go ahead and multiply. However, if they were not matching, then you would just say not possible. And you stop and you move on to the next problem. So that's kind of nice when that happens, but right here it works. So we want to move on. Now, also in blue, I mentioned that you actually find your result. So not only do you know that you can multiply the matrices, you know exactly what format you should be filling in once you get your result. So, like it says, when you multiply, expect your new dimensions to be those numbers. So I'm expecting a 3-row by 5-column matrix when I multiply A and B right here. So it may look kind of odd, but it does work out. And I didn't put numbers or variables into this, but you can see the blanks. So A is a 3 by 2, multiplied by a very different looking 2 by 5. But it works out to where you get the 3 by 5 in the end. Alright, take note of that. If you need to pause the video and take some notes, go ahead and do that. So secondly, let's actually do one. I've got a pretty neat technique I learned from the web. I got it off there. This is the first year I've actually used this. How do you actually multiply? R times S. So I gave you R in black and I gave you S in black. But in blue, this is my kind of answer thought. I want to make sure I can do these, or do this multiplication problem. So I notice I have a 2 by 2 matrix for R and a 2 by 2 for S. So I check my two inside numbers and they match. So that's what my check mark means. I can do this. So RS. The way I want you to set your paper up is I want you to put your first matrix on the left, and I want you to put your second matrix kind of diagonally above. So the two blue matrices are my question. Now, the green brackets, I know that I should have been getting the 2 by 2, but you really just fill this space in. And I did not fill in the red stuff yet. So once I put my blue in blue here, I drew a red line, and with you it might just be a pencil line, in between the two lines, and it created a 4-square box. So it tells me, I'll use my hand, it tells me that in this box right here, I should multiply 3 and negative 2. So the first spot and first spot, that was negative 6. And then the second and the second, so 2 and 1, that's a plus 2. I'm done with that spot. Next, I move over here. So I'm using the top row and the second column. 3 and 1 is 3, and 2 and negative 1 is minus 2. Down here, I use the second row, first column, so negative 1 and negative 2, first and first, that's a 2, and 0 and 1 is 0. And lastly, I still use the bottom row in the last column. So negative 1 and 1 is, well, I messed up. And that's okay. We'll learn from it. Let me get my marker. So negative 1 and 1 ought to be negative 1 right there. And 0 and negative 1 is 0. So when we go over here and we fill our answer in, which I'll change this one right here, negative 6 and 2 is negative 4, 3 minus 2 is 1, 2 plus 0 is 2, and now negative 1 plus 0 is negative 1. So you just want to check your work, and like I just did, and make sure you get them right. So this is your answer, and if you have this format on your paper, I'd be super happy to see that. That would be great. Let's do another one that's going to have different dimensions. So right here you see K times L. So our first thing we want to do, they both look different. Check your dimensions and see if you can do this. So K is a 2 by 3, 2 rows and 3 columns. And L is a 3 row and 2 columns. You see the 2 3s match on the inside? That's good. And notice that the 2's on the outside mean that we're going to get a 2 by 2 answer. And you see at the very end of the problem, we do. So again, I put my red lines in between the 2 blues, and I have my 4 quadrants. You won't always get a 2 by 2 matrix. I should have given you a different example, but we'll see some in class. So again, -3 times 1, -3. It's a lot smaller here now. And then 2 times 4 is +8 above right here. And 2 times 0 is 0. And if you go around the box, you'll see where these numbers come from. So again, to get the bottom spot on the left, -1 and 1 is -1. -2 times 4 is -8. 0 and 0 is 0. So I'm just doing first times first, second times second, third times third. If you ever end up with something that doesn't have a corresponding multiplier, then you've probably read the dimensions wrong and you can't do that problem. It should always work out if you have this setup. Again, I simplify it down to my green answer and I'm done. My answer is 5, 10, -9, -4. Alright, if you have any questions about this, please let me know in class. You were confused about how I got a certain number. Maybe you found another mistake of mine, and so let me know about that, and we can review the video and see where that happened. But again, this is a difficult topic because it's a lot different from anything you've done before, but try to understand it, look at more examples, create your own matrices, see if they can work. So always remember, flip, don't flop.